spectra, right? So basically what I'm going to do in this video, that I'm going to tell you that how a particular complex looks of a particular color. Okay, so how and why this happens, and why a certain complex shows a particular color for a particular complex. Okay, so these things we are going to understand in this particular video, so we'll start with it. So yeah, so basically you know that the things which you see, they are like, you can see something when it radiates a light of certain wavelength. Okay, so if a substance is looking like, let's say if a substance is looking red in color, so that means that it is radiating a light of the wavelength which is near or which is equivalent to the wavelength of red color. So that's why that compound will look red to you. Okay, and if something is looking black, let's say, so that means that that particular thing is actually, if something is black, that means it is not radiating anything, or you can say that whatever light is falling on that particular substance, it is absorbing each and every point of that, and it is not radiating anything, so that's why it looks black in color. Let's say if something looks white in color, so if something looks white in color, that reason behind that is it absorbs, like it absorbs the light and then it emits all of them. Okay, so it radiates all the light which it absorbs, so that's why those kind of things look white in color. So this is the basic thing, this is the basic phenomena, that why certain thing looks of a particular color. Okay, so we'll talk about color and spectra with the help of, or with the point of a complex. Okay, so it says that the spectra is a study of relation of energy parameters like wave number, frequency, and with material. So what we are going to talk about is energy parameters, means the things which relates energy of a particular thing, like wave number and frequency, wavelength, with a material. Okay, so when these things are related with each other, that is called your spectra. Now in absorption spectroscopy, transition takes place from your low energy to high energy. Okay, so that is called your absorption spectroscopy. That means it absorbs something and then electron electron take a transition from lower energy state to the higher energy state. Now the color rises when the interaction takes place with visible region. So that means the color, or the particular a certain thing looks of a particular color when the interaction takes place within the visible region. Means if the interaction energy is like within your visible region, in that case the thing will look of a certain color. Now if the compound radiates, if the compound absorb all radiation of visible light, it appears black. If the compound does not absorb any radiation of visible light, it appears white. So this is what I have already told you. So these are the 2 points which tells you. Now in the right hand side, which you can see over here, is your color chart. Okay, or you can say that what kind of colors in which your white color splits. So basically your white color splits into 7 different colors. Those are like abbreviated over here as VIBGYOR, with GYOR, where V stand for your violet, I stand for your indigo, B stands for your blue, G stand for green, Y stand for yellow, and O stand for orange, and R stand for red, starting from 400 nanometer wavelength to 800 nanometer wavelength. So the highest wavelength is basically of red, and the lowest wavelength is of violet within this visible region. Now below 400 nanometer, the wavelength or the light which is below 400 nanometer wavelength, that light is called UV light, like ultraviolet light, and the light or the radiations which are having higher wavelength than 800 nanometer, those are called infrared light. Okay, so this is the general introduction of the color spectrum. Now the energy level in compound are fixed with a definite energy gap. Hence, most of the compound absorb a particular radiation and color appears as its complementary color. So that means that the energy level which you will see for a particular compound, basically they are fixed with a definite energy gap. Like there is a definite energy gap, there is a fixed energy gap which is over there, and that's why the compound absorb a particular radiation, and it like the color appears to be its complementary one. Now what is complementary, I will just tell you in few minutes. Okay, so on the basis of energy parameter, visible light is further classified in different categories. So that's what you are going to get in the next slide. So this is the color wheel. Okay, this is what you are seeing over here in your screen. That is what is called as color wheel. Now over here you don't see indigo, but violet is there. Okay, V stand for violet, B for blue, G for green, Y for yellow, O for orange, and R for red. The wavelength range is also given to you. So violet ranges between 400 to 450 nanometer. then your blue comes from 450 to 490, green comes from 490 to 550, yellow comes from 550 to 580, then 580 to 650, and the last one is your red, which comes around 650 to 750 nanometer. So this is the range. So what does this color wheel tells you? That if certain complex absorbs light of violet color, then it will radiate yellow color light. Okay, so this is just a complementary thing which you have to see. So if something absorbs blue color, it will radiate yellow color, oh sorry, orange color. If something absorbs green color, it will radiate red color. So you just have to look to the complementary side of the color wheel to tell that what color the complex will be. So here is the example of it. So if your lambda is less than 400 nanometer, then your wave number will be more than 2600 centimeter, sorry, 26,020 centimeter inverse. Then the color absorbed will be UV, and the complementary color will be colorless. So your complex will look colorless over here. Similarly, any of these, like all the data is given in this particular table, so any of these you can take. So if it absorbs around wavelength of 490 to 550 nanometer, so the wave number corresponding to it is 18,000 to 20,000 centimeter inverse, and the color which will be absorbed will be green. And from the color chart you can see that the complementary color of green is red, so the complex will look red in color. Similarly, if you take just the last one, that means if this is the wavelength which your complex absorbs, so that will lie in this particular wave number range. So that means that complex will absorb basically your red color light, and it will radiate its complementary color, that is green. Okay, so like that you can easily find out. Okay, so how to find out these things? So this will be given to you in the question. Okay, so